I'm Scott Simi, Chief Content Editor with InDro Robotics, and on today's edition of our Soundbite micro podcast, I'm pleased to be joined by Guillaume Nepveu, CEO of Montreal's cutting-edge software firm Chaac Technologies. Bonjour et bienvenue, Guillaume.
Thank you, Scott. It's a pleasure to be here and to talk about Chaac and our projects.
Excellent. So your website describes the company as a leader in digital transformation. Tell me more about what Chaac does.
Yeah, of course. Chaac is a Montreal-based company. We specialize in immersive training, drone data capture, and AI-powered analysis. So we create ultra-realistic 3D digital twins of the real world, and by using drones, LiDARs, photogrammetry, and we integrate them into our virtual training platform or operational platforms. So our solutions can be used from everything from safety training to remote inspection, and we help our clients operate more efficiently, train more efficiently, and make better decisions in complex environments.
So when did the company form and how has it evolved since then?
So it was founded in 2014. So initially it was a data capture company. So we had mobile applications to capture data in the field. Over the years, we've expanded into integrating other type of technologies such as drones, virtual reality, and AI. And now we don't only train people in virtual reality, but we make them work more safely and efficiently in the field. So today we are a team of about 25 people. And we work with organizations such as the Department of National Defense, the Royal Canadian Navy, Transport Canada, and many others.
I understand Chaac was the successful applicant for a call for proposals from Innovative Solutions Canada for a project around field detection, so identifying objects of interest automatically. Can you tell me a little more about what that means?
Yeah, sure. Well, in simple terms, it's about teaching computers to see the world as we do, but faster, more consistently, and without fatigue. So field detection means using AI and machine vision to identify specific objects in images or videos, whenever from a drone, a camera, a vehicle, or another sensor. And the challenge is to make the system accurate and reliable, even in complex outdoor environments.
Now, I understand that this project has evolved to something of real importance, the detection of landmines on the surface of the ground. Before we get to how you do that, tell me about the particular type of landmine the project is currently focused on, known as a PFM1.
Yeah, the PFM1 is a small plastic, wing-shaped anti-personnel mine. It's often called a butterfly mine because of its shape. So it's particularly dangerous because it's hard to see, it blends in the environment, and is sensitive enough to detonate under very little pressure. And fortunately, its shape and sometimes even its color can make it look like a toy to children, which has led to tragic accidents in conflict areas.
Now, obviously, detecting something involves both AI and machine vision, machine learning. Tell us a little more about the process of making that possible.
Sure. The process starts by collecting a lot of high quality images of the target object in different environments, lighting conditions, and orientations. And afterwards, we annotate those images so that the AI knows what to look for. And then we train a machine learning model to recognize patterns to distinguish these objects from the surroundings. And over the time, with more data and field tests, the model becomes more accurate. And we integrate geospatial data so that every detection is tied to a precise coordinate.
Now, obviously, you don't want to be walking through a landmine field and looking with some sort of handheld scanner. So your software is built to work with drones and ground robots. What roles do these devices play and how do they interface with your software?
Yeah, drones and ground robots are essentially our eyes in the field. So they carry cameras or sensors, capture high resolution imagery, and send it back to the processing platform. Afterwards, the AI analyze the data in real time and marks the detection, feeds that into a mapping system so the operator can see where each object is located. So it's a way to see without setting foot in the dangerous area.
Now, you've partnered with InDro Robotics on this, and I was actually fortunate enough to see a recent demonstration, and I got to tell you, it was pretty impressive. Just tell me how a typical demonstration works.
Yeah, so we usually start by predefining a test area and we seed it with training mines or replicas. And a drone is deployed over that area to a set altitude and pattern, capturing imagery. The data is processed immediately with our AI system, which flags any detection and plots them on a georeference map. By the time the drone lands, operators can actually see where the suspected items are.
And you just touched on the georeferencing aspect for each detected landmine. Why is that important?
Well, the detection is tied to a precise GPS location. So, when the teams can navigate through the area and know exactly where the threats are. So that's why it's really important to have them tied to a precise location.
Now, let's say there were 100 of these landmines on the ground. How many would the system detect? In other words, what's your average hit rate?
So in control environments, our detection rate is above 95%, but of course in real conditions, it can be more challenging with the lighting, vegetation, and terrain can affect those results. But with ongoing training and testing, we continue to push that towards that level of reliability in the field.
Why is a project like this so important?
So landmines remain deadly after the conflict. So it's like a bad legacy of conflicts, with thousands of people getting injured or killed each year, often civilians and children. So they can make farmlands unusable, it can delay reconstruction, and keep communities in fear for decades. So if we can speed up the detection while keeping the miners out of harm's way, we can save lives and restore safety to affected areas afterwards.
And while you're currently focused on the PFM1, I'm assuming this software could easily be tweaked or trained to detect different objects of interest. Is that a fair assumption?
Yes, that's correct. The technology is object detection. So with the right training data, we can adapt it to identify almost anything from infrastructure, defects, or wildlife, or lost equipment.
Where is the project at now, and what's next?
So we've completed several successful demonstrations, and we're now preparing for a more complex field trial in a varied environment. So the next step is integrating the system into the operational workflows so that it can be eventually deployed in real-world missions.
And something I forgot to ask earlier. So the drone goes up and captures the imagery for your orthomosaic, but what role do the ground robots play?
Yeah, the ground robot acts as a way to cross the field and so that people can potentially follow it to cross a affected area, or it can be used to go and identify physically each mine so that they can be disabled.
On a personal level, why is this project meaningful for you and the Chaac Technologies team?
Well, at the root, our team really thrives in solving difficult problems that have real-world impact, right? So knowing that our work could save lives, protect communities, and make dangerous jobs safer, it's really motivating. So it's basically a technology with a purpose.
One more thing, where does the name Chaac come from?
Now, that's a good question. It's not an acronym. So Chaac is the Mayan god of rain and storms. It's a fitting name because we work often in operating areas that are unpredictable, challenging environments. So it reflects our belief also of harnessing powerful force, in our case technology, to bring positive change.
Is there anything else you'd like to add?
Well, I just want to mention that innovation is a team sport, right? So none of that would be possible without our team, right? So our developers, our 3D artists, and so on, and our partners and clients, of course. So with them, it's the only way to really push the limits of technology and innovation. So thank you to all of them.
Awesome. Guillaume Nepveu, CEO of Montreal's Chaac Technologies, thank you so much for your time.
Well, thank you, Scott. It's been great to share that with you, and hopefully we'll talk soon.
Awesome. Thanks again.